Okay, good afternoon, ladies and gentlemen. This is Professor DVG De Los Reyes. What I will be discussing this afternoon will be the finish assembly of a voltage regulator in which the output is variable. From my past blog, I have discussed this power transformer here. And what will I do this afternoon is that I will utilize two terminals which I needed in the assembly of a variable voltage regulator. So what I did is that I will utilize terminal 8 in number 9. The output voltage of this one from my previous log is I will try to see it. 8 and 9, it's almost 30 volts. It's almost 30 volts. And again, from my previous log after this, I measured the DC output without the regulator yet. The output is something like a 40 volts, the rectified. If we try to rectify this one by a, what you call this, full wave rectifier, the voltage that will come out is almost 40 volts. So what I will be using, guys, is that I will try to bring out one of my regulators over here. This is a kit for a voltage regulator. So I could bring out a variable voltage here. I will be using LM3710T. Okay. It is this one here. Terminal number 1 will be the adjust. Terminal number 2 will be the output. And terminal number 3 will be the voltage input. Meaning to say, the output of this one will be a variable. We inject a voltage on terminal number 3, that will be the voltage input, DC. The output will be coming out at terminal number 2. And terminal number 1, this is where we will be connecting terminal number 2. We will be connecting a potentiometer here, okay, plus a fixed resistor of around 240 ohms. And here, if we will be using 240 and a 5K potentiometer, if we try to rotate that potentiometer, we could vary the output here. And the range of the output is supposed to be 1.2 to 37 volts. With the given condition, the maximum voltage that will be applied to this LM317T here will be 40 volts. You cannot exceed 40 volts because this might break down. So the maximum input voltage for this LM317T will be 40 volts. So I will be utilizing the 30 volts AC. Okay, and like what I said, if we try to rectify it, the last time around we were able to measure 40 volts. Okay. So okay, I will try to remove this one here. Okay. And I would like to discuss the components of this voltage regulator here. What you call this variable output. This portion here is the rectifier portion, and the voltage regulator portion is this one here. This is the LM317T. This is the 240 ohms, and this is the 5K potentiometer. But unluckily, guys, I don't have a 5K potentiometer. the one available here is 10K. I use 10K. Then I adjust a little bit this 240 ohms to 270 ohms. And let's try to see what will be the output. Because if we could maintain this one as 240 and this is 5K using an LM317 voltage regulator, like what I said, the output should be 1.2 to 37 volts. But since the values, I changed this one to 270 and I changed this one to 10K, there will be a little bit discrepancy. But still, we could vary the voltage. Could you see it, guys? Okay. Okay, so let's try to connect. So I will be utilizing terminals 8 in number 9. The output voltage of this one is in AC is actually 29.6 or 30 volts. And if we try to rectify it by using this full wave rectifier, what comes out the last time around is around 40 volts. So, and I reconnect the output of this rectifier to the input going to the voltage regulator. The red one here is the input, terminal number 3. Okay? The adjust is actually terminal number 1. It is where the 240 and 5K is actually connected. And the ground portion is actually terminal number 2. Okay? So the input to the regulator is this red here and this black here. It goes to terminal number 1 and number 2. And the output of the regulator will be on terminal number 2. Terminal number 2. This is terminal number 2. Okay? So with the given, what you call this, color code, okay? This red thing here should be the plus output, and this blue here should be the negative, or simply the ground. So I will be using now my multimeter, multitester. I set it at voltage range, DC voltage range. So this is ready to be measuring a DC voltage. So the ground, I will connect the ground. And the red one, I will be connecting with the red one of the output of the voltage regulator. You see it, guys? This is the rectifier portion. This is the voltage regulator portion. And the output that we will be utilizing will be the output of the voltage regulator, in which we could vary the output. Okay? We could vary the output. So I will now try to plug in the AC transformer. Okay? And I will try to rotate this one. I will try to rotate it. It's increasing, okay? 17, 22, 26, 30, 35.14, and the maximum voltage that we could obtain on the output of the LM370 is 39.27 volts. That's the maximum voltage. So just in case you got an equipment which needs a voltage that's very near 39.33, you can use this one. This is rectified already. Okay? So I will try to listen this one. I will try to vary the rheostat. Okay? It's decreasing now, 36, 33, 26, 21, 17, 13.33, and for the smallest voltage that we could obtain here, like what I said, I changed the value to 240 to 270, and the potentiometer, instead of using 5K, I used 10K. So I could not obtain that 1.2 volts here. And let's try to see what will be the smallest voltage that we could obtain. Actually, the smallest voltage that we could obtain when this will be stabilized, it's 8.68 volts DC. That's the smallest voltage that we could obtain from this. And the maximum voltage is 39.23 volts. So by using this variable DC power supply, it seems we are using how many voltage regulator? 1, 2, 3, 4, 5, 6. We could obtain a 6 voltage regulator. Uh, it seems we can use a 9-volt voltage regulator by using this one, by adjusting it to 9 volts. And if we try to adjust this to 10 volts, we could obtain a 10 volts voltage regulator. And if we try again to adjust the potentiometer, we could obtain a 12 volts. And again, if we try to adjust the potentiometer, we could obtain a 15 volts. Again, if we try to vary the potentiometer, we could obtain an 18 volts. And the maximum voltage regulator that we could obtain here is actually 24 volts voltage regulator. Okay, that's it, guys. The smallest voltage, it has now stabilized. The smallest voltage that we could obtain here is 8.55 volts or 8.6 volts. So the smallest voltage that we could obtain here is 8.6 volts. The maximum voltage is around 39.23 volts. And if you try to vary this one, it seems you are using 6 voltage regulators. You can obtain a 9 volts voltage regulator by adjusting the potentiometer, 10 volts, 12 volts, 15 volts, 18 volts, and 24 volts. Okay? Can you see it, guys? Can you see it? So those are the voltages that we could obtain after the assembly of this variable output voltage regulator. We could obtain a 9 volt, a 10 volt, a 12 volt, a 16 volt, an 18 volt, and 24 volt from this setup by adjusting the potentiometer. If we try to adjust that one, this one potentiometer here, we could obtain these 6 voltages here. So this is a very useful thing, you know. I just utilize one of the terminals of this power transformer in which the output voltage is 30 volts. If we try to rectify it by using this pole wave rectifier, the output here is around 40 volts. So the input going to the voltage regulator, this is the voltage regulator. That's the one. That's LM370. The red one is the input. The black one, the red one is the input. The black one goes to the ground. So this is the rectifier portion. This is the voltage regulator portion. Okay, and these are the output. Okay. These are the output. And this is the power transformer that came from my other blogs. I just utilize terminal number 8 and number 9 in which the voltage is around 30 volts. Okay, I will try to place back my camera here. Okay. Again, I will try to rotate this one. It goes to 9 volts, 10 volts. $17 volts, 19, 20, 21, 22, 24, 26, 29, 31, 33, 35, 36, 38, and the maximum voltage is almost 40 volts. So in here, by rotating this one, we could bring out a maximum voltage of around 40 volts. Again, I will rotate this one counterclockwise. We'll go with the voltage output going down. 36, 34, 31, 28, 26, 23, 21, 18, 16, 13, 11, 8.82. The smallest voltage is 8.82. Yeah, that's the smallest voltage, 8.69. So as I rotate this potentiometer here, the smallest voltage that I could obtain is 8.8 volts, and the maximum is 39 volts. So by rotating this potentiometer, like what I said, it seems you could obtain 6 voltage regulator here. You can output a 9 volt, you can output a 10 volt, you can output a 12 volt, you can output a 15 volt, and you could output an 18 volt, and the maximum voltage regulator that you could bring out here from the standard value, it's 24 volts. So this is a very useful thing. Okay, that's it guys. That is how I assembled the rectifier portion and the voltage regulator portion to output a variable DC voltage on the secondary, utilizing my power transformer using terminal number 8 and number 9, in which the voltage is around 30 volts. Okay, that's it guys. That's it. That's the assembly of a variable DC power supply. This is the power transformer. This is the rectifier portion. This is the voltage regulator portion, and this is the output. Good afternoon from Los Angeles. This is Professor David de los Reyes. What I have discussed is the assembly of a variable output DC power supply by utilizing my power transformer, okay, a full wave rectifier, and the variable DC voltage regulator is actually LM, the code is actually LM3117T, in which terminal number 1 is adjust, terminal number 2 is the output, and terminal number 3 is the input. Good afternoon from Los Angeles, Professor David de los Reyes.